All right. In this video, we're gonna focus on calculation on open and closed pipe. Okay. But before we solve this question here, let's understand this question first. Okay. They said an open pipe. That means this pipe here is said to be an open pipe of length 33 cm. The length of the open pipe is said to be 33 cm. Alright. Resonates to a frequency of, the frequency here is 1000 Hz. They said, what is, these are the question here, class. Okay. What is fundamental frequency, the second harmonics of the pipe, and the first overtone? Okay. Now this question introduce us to open pipe, so that an open pipe is a pipe or the tube that is open at both ends. The tube that is open at both ends. Okay. In case this is your first time of watching this video, to get our video, that is the full video of open and closed pipe, that is the part 1, the introduction, you hit the subscriber button to get the full video of open pipe and closed pipe. Okay. So before we solve this here, let's try to know the formula of open pipe relating with wave parameters. Okay, let's get the solution of this question first. Okay, the formula for open pipe relating with wave parameter would say to be lambda is equal to 2L. Please take note of this. Lambda here is representing the wavelength, and the L here is representing the length of the pipe. Lambda is representing the wavelength, and the L here is representing the length of the pipe. Okay, so this is the formula that relates wavelength parameter with the pipe, the length of the pipe. Okay, so let's look into what we are asked to calculate, class. We are asked to calculate, the first question we are asked to calculate here is fundamental frequency. So let's know what fundamental frequency is before we calculate fundamental frequency. Okay, now we say that fundamental frequency is the frequency calculated from a given question, or the frequency from in that question. The frequency calculated from a given question, or the frequency in that question, is known as fundamental frequency. We can also call it force harmonics. Either I call it fundamental frequency or you call it force harmonics. Please take note. So though it means that this frequency given to us here in this question here is standing as our fundamental frequency. So the answer to A, that is the equation A, the answer to question A, F, is said to be 1000. Sorry for this. F is said to be 1. The answer to question A, F, is said to be 1000 Hz. Okay, now let's look into question B. Question B is second harmonics. So let's know the formula for the harmonics of an open pipe. The formula for harmonics of an open pipe is said to be F of n is equal to n of f of naught. Please take note. Where this f of m here is said to be the harmonics frequency, f of naught is said to be the fundamental frequency, and the n here represent the term of the harmonies. Okay, if I have this to be second term or second or first, if I have this to be second harmonies, that means n is said to be 2. If I have the equation to be third harmonies, that is n is said to be 3. If I have it to be fourth harmonies, that is m is said to be equal to 4. Please take note. So n represent the term of the harmonies. Okay, so now let's try to use this formula here. That is, let's use this formula given to us here to calculate for the second harmony. Of course, for second harmony, it means that our value of n is going to be equal to 2. So the value of m here, class, the value of m, the value of n is said to be equal to 2. Of course, our f of n, sorry for that, okay. Of course, our f of n is to be equal to f of n, sorry, to be equal to 1000 hence. So calculating for f of n here, we have this to be 2 times 1000. Our answer is going to be 2000 hence. Alright. So now let's solve the next one here, which is said to be the harmonies. So let's solve the next one, which is C. We are asked to find the fourth overtone. The next is overtone. So the formula for overtone of an open pipe is different from the formula for overtone for a closed pipe. Please listen to me. The formula for overtone of an open pipe is different from the formula for overtone of a closed pipe. Okay, now we are solving a question on a closed pipe. We are going to know the formula for the overtone of a closed pipe, but let's first of all finish up the question for open pipe. So the formula for the overtone of an open pipe is said to be f of n, that is f of n is equal to n plus 1 f of naught. And we know that we are asked to find the fourth overtone. Okay, from the question here, we are asked to find the fourth overtone. Okay, so the fourth overtone means that the value of n is equal to 4. So if the value of m is equal to 4, I'm going to have this to be 4 plus 1 times fundamental frequency, which is 1000. So I will have this to be 5 times 1000. My answer will be 5000 hence. So this is my answer here. So all you have to do to get the full video of open and close pipe is to hit the subscribe button, like and share. Thank you so much.